Time to play the game!
Hello. In this video, I'm going to talk about a new keyword, struct. Struct is a keyword that will allow you to create groups of data which will be linked all together. We call this a structure, actually, and we'll see that in a moment. I'm going to show you an example. Imagine we have a problem and want to do geometric calculations on points. Imagine. So imagine I have 10 points in an area. One of the methods to define 10 points in a 2D area with variables, we'll use ints. Let's not get crazy and use floats. So you'll have the choice to do this. Int x, square brackets 10, so those are x coordinates of your 10 points, and int y, square brackets 10, are your y coordinates of your 10 points. You'll always have to maintain your x and y together in parallel and position yourself with both. Okay. You probably think that's a bit boring. We could have, for example, done something called point, and here we'd have point 20, and here we'd have put 20, and said that all odd numbers are x and all even numbers were y. Or the other way around, same thing. So every time we wanted to access a point, we'd have to access a value, the +1 value, and then multiply each time by 2 to access the following point. It gets a bit hectic. Let me teach you a way to move around more smoothly between points and how to define what a point is. Those are called struct because to me a point is two integers. So how do we write it? We declare it struct and then the name. For example, let's call it s_point. We can declare a structure by doing this. Here you just say that it exists. It's a bit like functions prototypes. There will be a difference between declaring it and defining it. I'm going to define a directory. To define it, just like a function, I need curly brackets and end with a semicolon. So here in my structure, I'm going to define data that my structure possesses once I've built one. So for example, an int x and an int y, there. So based on this, I can, for example, declare a new variable of type struct s_point. We'll have to write struct2. That's important. The keyword ahead is important. For those of you who know other languages where the struct disappears, be careful. So the struct s_point, let's call it a for example, and now if I wanted to modify the x of my structure a, well, I'd have to write a.x. By adding the dot here, I can access the variable x from my variable a, which is a structure of type s_point. So now in x, I can put 10 for example, and in a.y, I could put 42. In a long list of structures advantages, for example, one of the advantages of structure is that when you want to copy a dot into another, you could do this. And now B is a copy of A. It means that if we modify A now, and B won't be affected, and vice versa. So B, now its X is worth 10 and its Y is worth 42. So that's a huge advantage. Watch out, when you do a function call, remember that we copy. So if you set a structure as a parameter, you'll get the exact position. You'll have to copy, in this case, 2" and risk doing heavy operations, which would take up a lot of memory, having ginormous implications, and it's probably going to happen. So in general, we use pointers to structures, and when we try to pass them, except if you know what you're doing, in which case it's okay. So we've seen how to build structures and how to add data in them. We can do what we want. We can even use floats. We can use chars or other structures and add as many data inside as we want. They just have to have different names. Except for x and y, those can't have the same name. See? It's just like normal variables. Because otherwise, we don't know which fields you want to access. So now, let me show you how to. The advantage of type def with structures. If you write this, type def struct s_point, and then let's call this t_point, what it does is that instead of writing struct s_point tabulation variable's name, it'll be able to write t_point and it'll be able to do the exact same thing. So here you see that type def helps save up lines. Well, save up width. That's a small advantage. Quite practical. And I'm going to show you something else. One last thing about structures. So we've seen we could add data in those. We've discovered a new operator, full stop /dot. There's a special rule for pointers. Imagine I want to create a pointer called PTR. PTR takes the value of my structure's address, structure A, so the thing is, in order to access the element X from A via PTR, in your minds, in all logic, we could have written this. Star PTR, full dot stop, X, because basically star PTR is the same as A. Had I written this, no problem, it works. There's another way to write it, using arrows. The arrow can replace the asterisk dot, meaning you're dereferencing your pointer. And behind, you're going to look for a structure's element, because the element towards which pointed your pointer is a structure. That's it. We've covered the basics of structures. As simple as this, and with these basics, we'll be able to achieve many things. It's a notion that we use a lot in C, so try and practice, because you'll see we're going to use this notion a lot.